Hello everyone. Uh, Yesterday we have covered few topic with data types. I think that have we completed the data types, data frame, and this all? Yes. Hmm. Lakshminder, we could choose any confidence level But in the default, we choose only 5 and the 1%. As per our confidence, we could choose that confidence level. Whatever the confidence you have in your statement of the hypothesis, you could choose your confidence level. If you have the 80%, you could choose the, but in default, whatever the research work you are doing, you must have the 95% confidence at least. Maybe more than that. Got it?
Yes, sir. Thank you.
So then it could be universally recognized your whatever the testing you are doing, hypothesis you are taking. Likert scale and the Likert type scale, I will explain you. I just share my screen with you so you could understand what is Likert type scale and what is the Likert scale. First, I open that PPT. Are you getting my screen? Yes. So I will show you that thing. What is the difference between that? I will show you it. Look at this. Likert scale and Likert type scale. When we write some item, we use some scale ordinal data like strongly disagree, disagree, not certain, agree, and strongly agree. This type of ordinal data we take. So that we write in this way. Suppose you have a one question that is you are asking in a Likert type scale, the 5 point, and you are getting the these are the respondents 1, 2, 3, 4. Yeah, you are getting this, and this is another question you have asked with them. And if you want to compare these two opinion of the person, and the first through the this question and second through the this question, both are the Likert type 1 to 5 scale. So it would be a Likert type scale. It could not be a scale. It is the ordinal data. So it is a Likert type scale and it is called the ordinal data. And the central tendency, what we could measure here, that is the mode and median. Mostly median is preferred. And the dispersion, we could use the range, quartile, and the mean absolute deviation also we could use for the dispersion. And association means the correlation, if we talk about, that is the Kindle and tau B or C for association we could measure here. And we could perform only the non-parametric test like the Wilcox test, chi-square test, Mann-Whitney test, Kruskal-Wallis test with this sort of data. Sometimes what happens, the few items, we add a few items and make some factor. Okay, we do the factor analysis, the post-factor analysis, we do the pre-factor is also there. We know that these questions belong to this factor, and as per the factor we have decided the question. That is a prefactor. So or after putting the question in a questionnaire and then you find out the reliability of the data, then you do make a factor analysis, then you sort out the factors. So that is a post factor. Some questions belongs to some factor and the other question belongs to some other factor, and then we find out some score. We could get the sum of the value, or we could find out the mean of those values horizontally. So suppose I am making this factor 1. This is my factor 1. I am adding these all questions here and I am taking the, basically we prefer the mean score. So I am taking the mean of this all. Suppose here 5, here 2, 1 and 5. So I add up this and divide by 4. So it is a 14 and divided by 4, 3.5 something. Okay. 5, 20, 14, 14, 4, 12, 4, 3 is 12, 4, 5 is 20. Similarly, I will get some other. So 5 and 3, 8, I am getting 2. In this way, I am getting 3.8 and whatever values I am getting. So these are the Likert scale now. This is a Likert scale. Got it? Lakshminder? This score is a Likert scale. Or this is a Likert type scale. Okay? And when we convert them
Yes, sir.
in score, we could apply, it is called a scale. Now it is an interval scale basically. And
Sir, I have one question. Excuse
yes,
me, sir.
yes, yes,
Sir, if this is the Likert scale, actually we know Likert scale belongs to ordinal scale.
yes. Generally, people say that is the Likert. That is not a
So how can we
Likert
use?
scale. That is a Likert type scale. Ordinal data, we
Okay.
have an order like a strongly disagree and disagree, and this is the order. We there is no fixed interval between them. Got it? As you in
Yes,
scale,
sir.
you see there is always a fixed interval. If you see the scale, you see the 0 to 1 centimeter and 1 to 2 centimeter, you will get the uniform distance. Got it?
Okay, sir.
So
Okay,
that
sir.
is the
Sir,
interval is
actually
fixed.
factor analysis.
Yes.
Okay. So actually factor analysis use the scale data or ratio data. But in
Hmm.
this case, these are not scale data or ratio data. So how can we use factor analysis by using this data?
Hey, we could use it because we have a two sort of factor analysis: confirmatory and exploratory factor analysis. So as per that, we have to decide which factor analysis we are going to obtain, and as per the scale also. Okay. And there are various method in the factor analysis, maximum variance, very max, and oblivion, and so many methods are there. So as per the method we have to choose, then we could apply according to scale. So that is a part of our R2. That is not a part of R1. Okay. So I will explain there about the factor analysis in detail, or how we could perform the factor analysis in R also. Okay. So here we have a central tendency, mean, dispersion, standard deviation, association. We could use the Pearson, and the parametric test we could apply t-test, g-test, and whatever. Okay. There is one more thing which I would like to explain you. In the traditional method, whatever the value we are getting here, so what category this value will belong? 3.5. Because the one is for the strongly disagree, two is for the as per that. So what would be the range and where it will lie? So the traditional was the mean score technique we used there, but it was not scientific. As you see here, we are getting from 0.01 to 1, it would be a strongly disagree. And 1.01 to 2, it is disagree. In this way, we are getting the interval. You know? So this value 3.5 will lie here and it would be agree as per this traditional method. But you know that the our Likert type scale are using value from 1 to 5. And can you get the mean less than 1? Yes.
No,
Can we get the mean less than 1?
no.
So how this traditional method is scientific? It is not scientific because it is telling that the 0.01 to 1, if you get the mean score, then it is strongly disagree. Okay.
Yes, sir.
So this is totally wrong. And in the most of the research paper and the PhD thesis, I have seen this. And this is unscientific. Then some people use this one, and I have given one name because no name was there. That is a range max method. we apply. So I have given the procedure as per the Likert type scale. If you are using the 5 point, you will get the range of that, whatever the scale you are using. If you are using the 7.7 minus 1, the range would be 6. Here we are using 5 points, so we are getting 5 minus 1, 4 range. And this range we divide by the maximum. So maximum is 5 here. So we divide by 5. And whatever the value we get, some fractional number we get here, that is the 0.80. So what we do, we will put the lower limit 1, where from where it will start, and add on 0.80, we will get the upper limit of that class. So it is 1 to 1.80. The next will start from 1.81, and we again add 0.80 here. In 1.80, we will get the next upper limit. Then again we add 0.80, we get the next. In this way we get the 5 at the last. So here we are getting the same interval. Okay, difference is same.
Yes, sir.
And this one is scientific. So the value 3.5 will lie in agree. Where it will lie? Agree. Here also it is coming in the agree, but here also it will come in the agree. Okay, but if you have a value 3.2, then it will be not certain. Got it?
Yes,
Does
sir.
that make sense to you?
Thank you, sir.
So this is a scientific way to give the class to these values. Kirti, yes, you want to ask some question?
Yes, sir.
Please.
So, sir, suppose if we are not converting items of a scale
Okay.
using factor analysis,
Okay.
so then we cannot call it a Likert scale, right?
Yes.
Only after factor analysis we can call it Likert scale.
Yeah, factor analysis, or you are adding some questions. The prefactor you have taken already. Sometimes we take the prefactor. No? We decided this question belong to this factor. As per the factor, we have decided the question, the predetermined, we have decided some factors, and on those factors we have put some questions. Understand?
But it
So,
has to go through the process of factor analysis, right? To call it a interval scale. Matlab, we have to check the psychometric properties and
yeah,
all.
yeah, yeah.
Sir, one doubt also. So suppose,
Yes.
as you said that we have to calculate the mean, like the total score. So if we take the total score of a factor, we
Hmm.
can't.
Yes. You are not audible.
Sorry.
Yes.
So suppose, so if we take the total score and do not convert into mean, can then we also matlab, use it and do other
Yes.
kind
Yes.
of
Yes.
inferential
Yes.
statistics?
Yes. Yes. If you get the sum, that will you will also apply. It will convert in the Likert scale automatically.
Okay. Thank you, sir.
Okay. If you don't take the mean, if you take this value, that is 14, and here you take, so this is also a Likert scale now.
Okay.
Understand? It is called the score.
Hmm.
It's the sum score. We could take either sum score or the mean score.
Okay.
Okay.
Thank you, sir.
Oh. Now let's continue our session. I just clean this and remove this. So yesterday we have seen a few data types up to the data frame we have studied over there. Now I would like to tell you something. Uh, uh, Few basic commands we will study in this third day session, and it is the day third we have. In the day third, we will study some basic syntax of R. So first syntax, what would I would like to tell you. Syntax is a function we use in R, whatever. So first syntax I will explain you. That is a sub and G sub function. So what is the syntax of sub and G sub function? So I will tell you the syntax. What does it mean? Syntax of the sub function. Sub function is for the substitution, and G sub means the gross substitution. So first we see the syntax of sub function. The syntax is attributes is same. The attributes, whatever the arguments we say inside, we write in the function. Those are same. So there are few required arguments. There are two sort of arguments in a function. Few arguments are required, that is compulsory to write, and the some arguments are default. Okay, so it is not compulsory to write. If you want something else, then you will use the value for the default arguments. So here the first is a pattern, second is a replacement, third is data. These three required arguments are there in the sub and G sub function, in both functions, the same arguments. So suppose I will take one example here, and this vector I am making, this is the address, and we are writing in the quotes ch oblique 206 scheme number 74 C Vijayanagar Indore. It is the address, and I want to substitute hyphen instead of forward slash. I want to change this. Okay, or this is my object name, this is my data, and this is the pattern, and the replacement would I will take the hyphen, whatever I want. So if I run this and I will show you I will print it. Look at this, we are getting this. Okay, I will just remove this also, it would be better for you. I again run this because it is not in my environment. Now it is in my environment. So this is my address. Now I use the sub function sub, and this sub function I am using the pattern. This is my pattern, and I want to change this with the hyphen. Got it? Then the third argument is data. Data is add. Understand? And if I run this, you see the difference in the both. What is the difference you are getting there? Yes. Can somebody explain me after watching these two print? What is the difference? So we see that it has changed only first forward slash. It has not changed the all forward slash. So sub function will change the only one, which one is in the front. And again, I use this sub function, and I give some name to this. Add one. I will show you. Here I will show you the add one. Add one is that what I have printed there. The same thing. Now I am taking another one, add two. And here also I again use that sub function. I am taking add one as a data now. and I will see, I will run it and I will get the A2. Now I will print it for you. You see what is the difference between that. Now we have, it had converted one more, but I want to convert all the forward slash in one shot. So then I will use the gsub function. So I am using the gsub function and taking the 83 and gsub, and I will use the same arguments are there. I am using this in add. Add is the first one. This. So it will change all the forward slash in hyphen. You will see. I will print 83. Look at this. Is it clear to all? What is the difference between sub and gsub function? Okay. Now, where we use it, that is very important. And in the data analysis, where you use. So I do one thing. I take one data set, read here, import one data set, and we see where we could use it. For that, I'm using one data set, and that is I am giving a name MD, and read.csv file format is for that data set. I have file.choose, and I run it. I will get one pop-up window, and here I will see that data set is in this data set. In data, I will get that loan data. So this data I am reading here. You see there are 2,500 observations and the 15 variables we have in this data set. If I click here, I will get the view of this data set. And here you see this particular variable I am talking about, interest rate. You see there is a percent symbol. I want to remove this percent symbol. Otherwise, I could not calculate the thing. I could not apply the mathematical operation here. Before that, I would like to show you the structure of this data. str is a function for structure. Whenever we read data, then we see the structure first and we view the data. There are two things. View the data and see the structure of data. Understand the structure. So it is the MD. And I will show you this structure is here. You see the first variable, which is the ID. That is an integer. Other variables, the amount requested is a character, but there are numbers. So why it is character? Because the codes are there. So we could convert them in a numeric form while removing these codes. So I will show you how we could remove these codes out of this and we could convert in a numeric form. This also we could easily convert in a numeric form. But when we try to convert this in numeric form, it will not convert directly. First of all, we have to remove this percent symbol. And then we could convert this in a numeric form. Does that make sense to everyone? Yes. So what I do, first I show you how to convert the first variable I convert in a numeric form, this one, amount requested. How do we convert? There is no percent sign, but I will show you how to convert this in a numeric format. It is a character right now. I will write the data name, whatever I have given here. Then I will use the dollar symbol. I will get all the variable names in the drop down. I will select what I require. Then I will assign it and assign it some function as.numeric. I want to convert this data in the numeric format, this particular variable. MD dollar, the same thing I will write here and I will run it. Now I will show you this warning. Don't be afraid from this warning. NS, because some values are the NS, some missing values are there in that variable. So it is showing that. And now again, I show you the structure. So when you see the structure, you see it is numeric now, amount requested. There is no quotes now. So now we could apply mathematical operation here. Now I will show you how we could use the sub and g sub function and how we could remove this percent from here and then we convert in a numeric form. So look at this. Same procedure I will apply for the interest rate. And I will use the g sub function first because I want to remove the percentage from all the values. And that is the pattern is a percent which I want to remove. And the replacement, I don't want any replacement there. So I will keep it blank. Even I will not use the space between the quotes. And then the data name, MD dollar interest. And I run this. Now I'll show you there is no percent symbol is there. Are you getting any percent sign? No. And if I show you the structure again, you will see there is no percent symbol, but still it is character. Now I will convert these in a numeric form the same way as I converted the amount requested. So MD dollar interest rate and S dot numeric MD dollar interest rate. Got it? Now I will show you the structure again. Look at this. This is non-numeric. Does that make sense to everyone? Here we use the G sub function or the sub function. Yes.
Yes.
PubDem is asking putting aid in front of the data set. Aid. Where what you are asking about this aid?
Yes, sir. Yes, that idiot.
This is the object name. You could give any XYZ, whatever you want.
Oh, okay, okay.
So this is the address of our office. So I have taken the abbreviation of address.
Okay, okay.
You could give any name, XYZ, whatever you want. Okay.
Okay, sir. Thanks.
So now you understand the sub and G sub function and its utility. We have to use it.
Yes, yes, sir.
Okay. So next we see the next function is paste. Whenever we write the function, always a bracket. And paste 0. This function we will study. This function we use for the concatenation. Means we are concatenate two things. It may be number or it may be one number in one character or the string, and both may be the strings. Okay. So I will show you. I will take X as Cypher and Y as Analytica. And I run this. I am doing some mistake here, but I want to hear from you why we are getting this error. Yes, Frank, we are providing the list recording link. These all videos after completion of the lecture daily uploaded on the YouTube, but it is all in the unlisted or the private mode. So the candidates who had paid for this course a little amount what we are charging for operating, that is a little fraction of the operating cost of this, because I am not only alone. There is a company, there are so many employees are working behind this. So we provide them the link of the study material, link of the script, the assignments, and the data sets, everything we provide them. Uh, and from there you could access the material, whatever. You could access the link of this video, you could see this video, you could watch this video, sorry, and you could download also all the stuffs. Correct, Kirti. Inverted comma, Adil is also right, Darsana is right. The quotes is not there. So that is very important. Always write the quotes when you are using some letters. Okay. Now if I run this, I won't get any error. Now use the paste function. X comma Y. There is nothing. The attributes are the required attributes, or the arguments are only the vector what you are taking, the data what you are taking. I just show you. It has been concatenated with a space. Okay, there is a space you see in the Cypher and the Analytica. And if I want something else between Cypher and Analytica, so I will use some separator between them. That separator I have to write in quotes always. So I'm using the plus. And I run this. You see what I am getting in between. So I'm getting the plus sign, Cypher, and you could write anything in between. You could use the hyphen, you could use anything, any name, any letter, anything. So this is the paste. And there is a paste 0. Look at this paste 0. What we are getting here? We are not getting any space in the paste 0. Paste 0, there is 0 space between the both variable. Same thing we could perform through this also, the paste function. You don't write anything here, even you don't give any space, and you run it. You will get the same thing, same output. So there is a paste 0, you could either, or you could use the paste also. In the paste, we have to use the separator. In the paste 0, we don't have to use the separator. Now I will tell you some more thing about this. You know that one thing I will tell you, if I write the letters in English, the small letters, you will see I will get the all ABCD, all alphabets of the English, small alphabets. If I write in capital and I run it, I will get the capital letters. So what I am going to do here, I am going to take one variable X, and X I am taking 1:10. This would be the integers. If I show you the print, so I will get the 1 to 10 values. In the Y, what I am doing, I am taking the letters, and I am taking only first 10 alphabets. So I will use the square bracket for the position, and 1:10. And I run it, and I will show you why. So these are 10 letters I have taken, the first 10 letters. Now I am concatenating it. I am pasting it. So I will use the paste function. In this paste function, I will write the X comma Y. I am taking separator as asterisk. Generally, you know that asterisk we use for the multiplication like that. And we have to use the quotes, sorry. And I run it. Getting it? Does that make sense to everyone? 1A, 2B, 3C, 4D, 5E, 6F, G, in this way. Now, we could collapse it. So we have another attribute, or the argument you could say, that is a collapse. So we are collapse it by plus. So you will see it has been collapsed now. Got it? Where we use this paste function. Suppose you are working in a bank and your manager asked you, please you give me the list of one column list of the person amount requested for loan and loan purpose. These two I want, but in one column only. So you could make new column in this data frame. He asks you, please you add these two column and in the data frame and give me the link or whatever. So what you will do here, you know that here we have 15 variables. I will show you the last variable also. This is the employment length. And now I will create one new variable. How we create a new variable in a data frame, I explain you. You just write down the data name, MD, then dollar, then whatever the new column name you want to. So I will show you new column. It is a new column name I am giving. And then how this column I am making. So I am making through the paste function. In the paste function, I am taking the column amount requested, then reason. So MD dollar purpose, loan purpose, and then I want some separator. So we could distinguish it. So I'm using the slash and I run it. And then I show you this data and you will see here, we are getting a new column. There is a amount required and there is a reason, purpose of the loan. This amount they are demanding for a loan as a photo for paying the amount of the credit card, bill of the credit card. So in this way, wherever you see there is a NA also, some values are the NA, there is a missing values in this amount requested. They have not mentioned the amount what they want, but they want the amount to pay the bill. But they have not mentioned the amount. Now, similarly, you could get also here somewhere NA on this one also. So does that make sense to everyone? Okay. Now the next function is substring. This function we use, suppose we have an IP address. I am hypothetically writing some IP address. This is the IP address, but you see that it is the substring. So it is not a string. So it should be a string. Okay, I run it. So this is my, and I want to pull out this up to here. So it is the third location of the string, first, second, third. Fourth will be space 5, 6, 7, 8. Third to 8. So I want to pick it out from this string, third to 8. So I will use the substring function. In this substring function, I will write the data first. Then where I have to start? I have to start with 3 and end at 8. 8th location. So I'm getting here 0 space 2, 3, 5, 4. Does that make sense to everyone? Got it?
Yeah.
Now I will tell you where we use it. Sometimes we have a data in a class interval format. And at that moment, we use this function, substring. Okay. So I will take one example. Look at here. I will show itself here. This is my column. The class interval is given 152, 249, 242, 349, 352, 449, 452, 549, 552, 649. This sort of data we get. We have done so many questions in our college time of the statistics with this sort of group data. So what do we first manually when you get this sort of column? Yes. What do we?
Midpoints. We calculate midpoints.
Correct. All right. So we find out the midpoint of this. We add on these two and divide by 2. So that is the mid value or the midpoint or the class mark that we called it. So how we get, but it is a string because the hyphen is there. So it cannot be converted in a numeric form because if there is something else than numeric, then you could not convert that in numeric. If it is a pure number, we could convert this in numeric because it is a pure number. No? It is a character now, but we could convert this in number. But we could not convert this in a numeric form. So first of all, we have to remove this. If we remove, then you are unable to separate this. So we will use the substring. So this variable name is the variable one I have written. You could give any name to this. And I will show you this. So it is look like this. And hypothetically think this is a column. It is a vector, so it is horizontal form. And I use the substring function on this variable one. And first 3 I am taking out. From 1 I will start and 3rd I will end it. And I will show you this. I will just show you the V1. So you see, this is my V1. 150, 250, 350, 450, 550. The lower limit I am taking out. Does that make sense to everyone? And still it is in under quotes. So what I will do, I will convert them in a numeric form. So V1 is s dot numeric V1. And if I print now again, look at this, I will get without quotes. So now it is a mathematical operation could be applicable on this. Similarly, I am doing for these 3 positions, last 3 positions. So it is the 1, 2, 3, 4th is a hyphen. So I will start with 5 and add with 7. So you see 5 to 7 I have taken the variable 1 itself and substring function I have applied. And if I show you again this V2 and we will get these are all strings. And we convert this in a numeric form. And I will show you again. So we'll see there is no quotes. Now I will create a new variable V3, which is a V1 plus V2. We have a V1. This is my V1 and this is my V2. So I will add on these two and divide by 2. So what I will get? I will get this mid values. Does that make sense to everyone? I will show you that sort of column is here. Look at this FICO range. Getting it? Okay. So in this column, we could apply this sort of thing. So substring you understand. Now next function is a repetition. In a repetition, if I use this function repetition and I write A 5 times. So I'm getting the A 5 times. Whatever the data you write first, then you write the how many times you required it. And if I write, I could use any number also for the repetition purpose. I could use I want 9. How many times? 10 times. So 99999. Is it clear to all? We have some more than one also we could repeat. Suppose I want to repeat A. B. I want to repeat this 4 times. You will see I'm getting the AB, 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 AB 4 times. But again, I am writing this. And I run this. Oh, what's the problem? Sorry. Look at here we are getting AB, AB, AB in the previous case. In the each equal to 4, I am getting the A 4 time first and the B 4 time later. Is it clear? Okay. So this is the replication. Now we come to next function, that is sequence. You know about the arithmetic progression or the arithmetic series or the arithmetic sequence? Yes. Do you know about it? What is arithmetic progression? Yes.
Yes, we know about it.
Okay, so you all know about it, so there is no need to explain it. I just write the syntax and show you the output. In the sequence, I want from 3 to between 3 and 47 with a difference of 4. Common difference I am taking 4, and it will start with 3 and it will make the sequence of with a difference of 4. So you will see 3 plus 4, 7 plus 4, 11. In this way I am getting. If I write here instead of 47, 49, you see I will still get up to 47 because if I add on the 4 on the 47, I will get the 51. That will not be possible for me to include because I have to take up to 49 only. So it will give me the sequence up to 49, whatever the sequence will be developed over there. I have another technique. Suppose I want a sequence 3 to 49, but I want length. I want 7 numbers only, including 3 and 49. So it will calculate the common difference and then it will divide it in the same part 3, 10.66, 18.33 in this way. So the difference is common, but it will include the 49 also. 3 and 49 will be included. Got this sequence? Okay. Next function I would like to explain you, that is sample. What do you understand by the sample? We have a population and we take some sample from the population. Okay. Suppose we have 1000 observations and I want 100 observations as a sample. So how do I select that 100 observations out of 1000? How do I select? I will take the first 100. I will take the 100 from second position. I will take the 100, and then how I will do that. How I will take out the sample. Yes. Can someone tell me what, when we select the sample, what is the characteristic of the sample? Yes. Correct. Lakshminder, you are right. We use the random. Darsana is also right. We choose the randomly. Okay. Kirti, correct. So I just do one thing. If I write this and run this, I am getting 1 to 10. Again, I run this, I will get the same sequence. But if I use a sample 1:10, then you see what happens. Next time, then next time, I'm getting the same in the sample. I'm getting the random number. In the first sample, when I run it first time, then I have taken the 3, then 8, then 6. And the second, I have taken 3, 9, 2. And the third, I am taking 2, 3, 6. Randomly, I am picking it up. Every time, I will get some different sequence. So, suppose it out of 10, I require only 6. So, I will get this 6. I will get this 6. I will get this 6. Every time, I will get the different. But if I write here replacement true, then what will happen? Here we are getting all different numbers because we have a data size is more than our sample size. There are 10 data points and we require only 6. So we will get all different. But when I write the replacement is equal to true, then you see what will happen. So some numbers are repeating or some numbers may not be repeat. Sometimes it may not be repeat. You see, I run it again. You see. So repetition, we have allowed it. Here see, there is no repetition now. If I have taken the replacement is equal to true. So sometimes it may give or sometimes it may not be. It is free. Okay. Here it is 3 is 2 times. That is the replacement is equal to true. Sometimes what happens, we have very few data and suppose we are using a Likert type scale. I want to create one column. I have 1000 observations and I am manipulating, I'm making a dummy data using the 5-point Likert type scale, like the strongly disagree, and not certain 1, 2, 3, 4, 5 in this way. Then what I will do, I will give this data name something I could give. Likert I am giving object name, and I'm taking a sample of this. I'm taking the sample from 1 to 5 integer I will choose. And how many times? 1000 times. So here you see the data is small and the sample is big. So replacement is very compulsory to be true. If you don't write the replacement true, it will not work. It will give you some error. And I run this. And I will show you if you want to see. You see, in this way, I am getting these values 1, 2, 3, 4, 5. In this way, I am getting 4, 5, 3, 4, something like that. And what I do, if I see the table of this, table is also a function which we use for the frequency distribution. If you want to see, we could use the table function. So 1 has come 194 times, 2 198 times, 3 208, 4 208, and 192 times. So it is approximately the same ratio, all the 5 values. Next time if I run this, so I'm getting different frequency, but it is approximate, near. Always. There may not be a big difference. There may be difference, but not be a big difference. Suppose I want one only out of 1050 times, approximate. So I could give them some probability, and that I will give in a vector. So I'm using 0.05, 5%. I require only that, and 15% I require 2, and 30% I require 3. So it is 50, and 40% I required 4, and remaining 10% I required that. I write the 0 here also, so it would be the same. So it is 1, the exhaustive, it should be exhaustive. So it is the 0.05 and 0.12 is the 0.2, 0.2, 0.3, 0.5, 0.4, 0.9, and 1. And I run this. And then I show you the table. Look at this. We are getting the proportion what we have given to it, approximate. Next time you run, you will get the other table, but it will follow the same instructions what you have given to it. But it will not be a fix. Understand? So we have given our probability distribution, what we want. Does that make sense to everyone? Yes? Suppose you are doing some analysis work, and today you have created this variable, and the next day you are working on this. In the previous day, whatever you have created, next day you will get some other sample. You will get some other. You will not get the same. Next day you will get some other thing. So you want the same what I have got yesterday, I want the same today also. The next day I want the same. So there is you have to use some seed. You have to set some seed. So I will use a set seed function before it. And I could use any value from 1 to 9,99,919. Any value as a seed. So there are so many seed, and behind every seed there is an algorithm. So it is not actually a pure random now. It is a pseudo random. So whenever you use that seed with this function in any system, in anywhere in R, you will get the same result. You are getting the same value because you are just running this again and again. You run this first and then run this. You will get the different value, Darshana. First you run this and then run this. Don't run this one, is not required. If you just run, so it is already been created now. You are just making the table of that. So it will be same always. So here I am using any number from 1 to, so I am taking 1, 2, 3 and I create it. Next time I run along with this set sheet again, You see, is there any difference? I'm getting the same sequence. So set seed is required. It is a pseudo random. We are taking randomly, but it is not a pure random. The particular random algorithm will work for you again and again if you use the set seed. If you don't use the set seed, then it would be a pure random. There is no algorithm. It randomly pick up the number. Is it clear to all? Now, you have seen the set seed and the sample. We could use any set seed, not compulsory to write the 1, 2, 3. You could use any. Here, I suppose this I am taking every time I am taking some other, and I am using here set seed 1. You could use any set seed number. The next time you have to use the same if you want the same result. You see, if you do in your system, you will get the same sequence what I have got. 94127, 947127. Got it? Adil, you got it now? The set seed, you could use any number. You could use 222, you could use 33, but whatever you write in the set seed, you don't change it. You use it the next time, then you will get the same result now what you got last day. So why we are using the set seed? Okay. After set seed, we have a function match and percent in percent. Match is a and percent in percent. Percent in percent is a infix function. So I will just take that script and I will not write again and again. It will take more time. So match and function percent in percent I will use here. So you see, I have created a one vector kj $1fk. Or here you see we have three letters kj and k I am removing from here. Okay, I just keep it. So I have three letters k, j, f, and the k is repeated here. This is my first vector. Second vector, you know that letters, if I run this, I will get the 26 alphabets like this. I want to match x in y. So I will use the match function x comma y. So it will give me the position. So where the k is in y, where the x is matching in y. So the k, where the k is matching in y. So k is matching at the 11th position in y. Got it? J is matching at the 10th position of y. Dollar is not matching. It is not there in y. 1 is not matching. Is not there in y. F is matching at the 6th place in y. And k is again matching at the 11th position in y. Does that make sense to everyone? Okay. Now, I will use the y comma x. So it will show me where y is matching in x. So A is not matching, B is not matching, C is not matching, F is matching at the 5th place. So F, you see, it is the 5th place in x. Okay, J is matching at the 2nd place. K is matching at what we are taking J, Fj, and K is matching at the first. It will go me it will give me the first one. It will not give me the second position. So I have written the 2 times K. It will give me the first position. It will not give me the 6th position. And then NA. Okay. This is a matching. Now we see percent in percent. When we use this sort of function, it's called the infix function. This is a suffix, this is a prefix, this is suffix. It is an infix. Infix function is being used between the vectors or the variables or the data. So first, what you are using, the first variable, that is called a prefix. The second you are using, it is called a, and this is an infix. So X percent in percent Y will give us the logical response like true and false. So first is matching in X, second is matching in X, third is a dollar which is not matching, fourth is a 1 which is not matching, fifth is matching, sixth is matching. Got it? Similarly, we could do the Y and X. So in this way, it will give us the true and false. But if you want to know the which value is matching, we have not got the value up to now. In the first match function, we have got the position. The second infix function, percent in percent, we are getting the true and false. We are not getting the which value is matching, which is not matching. So for that, I have one technique. I will use this square bracket in this infix function, and whatever my prefix, I will write outside also that bracket, that prefix, and I will run it. So it will give me which are matching. K is matching, J is matching, F is matching, K is matching. I could use Y infix X also. So here you see the Y, the first I have to write outside, and I will get this F, J, and K is matching in X. Is it clear to all? Now, I am giving some name to this function, and I will show you this T. T is a logical true and false, and I am converting this in a numeric form. This T, this true false. So true will convert in 1, and false will convert in 0. Got it? Any doubt here? Now we see which function. Which function will return the position of the element. So we have a letters. We know that it mentioned the 26 letters, and the which is equal to K. So it will give me the position of K. It is the 11th position. Similarly, I am creating one variable here, vector, numeric vector, that is the 11, 52, 85, 47, 69, and I use the same way, which function. So which X is equal to 5. So 5 is equal to 5. It will give me the value, return me the value. That would be 5. Oh. Why it is not giving me? Okay. Got it. Got it. Five is equal to 5. There were no 5 in the previously. I have written there 52. So 5 is equal to 5, or which is not equal to. Not equal to, you will use the exclamatory symbol before equal. So X is not equal to 5. So you will get the 11, 85, 47, and 69. Got it? So this is the about the which function. Next function is the sort and order. So we have a sample. I am creating a sample letters 1 to 10, 100 times. So look at this. These are the letters. I have taken the sample. And I will sort X. Okay. So you see, I am getting the arrangement as per the dictionary. A, B, C, D. A first time, then B, how many times is there, and then is in this way I am getting it. And if I order, instead of sort, I use the order, then you see what happens. So it will give me the position. You will see the third as the first position, then 20th as the second position. So the order will give me the position. If I want the value with order, so I will use the same technique which I used with which and percent in percent. So I will get the same thing as I am getting with the sort X. These both output are the same, this and this. Okay, either you could use this technique or you could use the sort function. I will tell you about the when you want the sorting in a different decreasing order. You write the decreasing equal to true. If you write the decreasing equal to true here, we'll see we are getting it this way. Does that make sense to everyone? So this is the sort and order. Now the reverse function. If I return this variable, this is the TWSUAV. Reverse is just it flip the vector. So it is the A is here now, then U, then S, then W, and then T. It is not arranging, it is just flip it. Table function I have explained you already. So we could make a table. This is the X, and I want to make a table of this. So I'm getting the A 31 times, B 69 times. So, and length function, we just see how many elements are there. We could use the length function. Then we have the function unique and duplicated. Whenever we get some data, we got some sort of deficiency, or you could say the ganks in the data. That may be that there may be some duplicate rows in the data. There may be some missing values. There may be some outliers in the data. So here we are talking about the duplicacy of the data, how we remove the duplicacy of the data, how we check it. So I am making three vector: name, age, and religion, and I run it first, and then I make a data frame with these all three vectors: name, age, and religion. So it is my data frame. You look at this: name, age, and religion. This is my data frame. Mani is 45 Hindu, Reshma 34 Muslim, Savita 23 Hindu, Mani is 45 Hindu. So it is repeated here. And the Kavita 25 Hindu, Reshma 34 Muslim, Siba 38 Christian, Mani is 23 Hindu. So in this time, the data we have. And if I see the uniqueness in this data, df, so I will use the unique function. So look at here in the unique function, there are 8 entries. Here you see Mani is 45 is not repeated again. It is the Mani is 23. It is not the Mani is 45. It is not a duplicate entry. Okay, age are different. Reshma is 2 times here. Here is only 1 time. Savita is 1 time. All are 1 time. So this is the unique. But the problem is that here you are getting the old index. 1, 2, 3, 4 is not there. So it is not converted, substitute 5 instead of 4. So this is the indexing, we'll get the old indexing. Duplicate df, there is also a function duplicated df. So it will give me the logical response, like the false first will not be duplicate anywhere in the data. Second is also not duplicate. Savita is, but the money is, this is duplicated, so it will write the true. Second time whenever it will come, it will do. The third time it come, it will tell you the true. And not duplicated if you ask about, not exclamatory symbol and the comma after that, it means all column I required. And I've used the same technique. I want, instead of true and false logical, I want the value. So you will see, and I will just show you this. I will just show you this. So you see this. Got it? I again make this, and so this you are getting the same thing. 1 2 3 5 7 8. There is a dplyr library which we use for the data manipulation, which you have to install first. And there is a distinct function. So you will see in the distinct function, we are getting the 1 2 3 4 5 6. So it is re-indexing. So I prefer to use the distinct function instead of unique or the duplicated for removing the duplication. Does that make sense to everyone? Okay. So it is all about the duplication. Now we see how we merge the data frame, how we could join the data frame, how we could merge the data frames. So for this, I'm making one data frame with 10 observation and 2 variables, ID and age. This is my first data frame. I will show you. This is my first data frame. There are only 2 columns. And the second data frame, I have a gender, 1 column. And second column is the education. So if you see this, so these are the 2 columns, and both the data frame has the 10 observation. And I want to merge these 2 data frame. So there is a C bind, column bind, because I want the next column gender here and then education in the data frame. So I will use the C bind function, and I will give the new name df3 C bind df1 comma df2, and I will show you this. So this is my new data frame. It is the merging. Whenever you do the C bind, the number of observation must be equal in both the data frame. Second thing, I am making another data frame, that is a df4. There I am taking the 5 elements, 5 IDs, 11 to 15, age, gender, and the education. So I will show you this also. So this is my df4. Now I am merging df3 and df4. The columns are same, so it will be the row bind. Whenever you do the row bind, the column should be same. No? And the observations may be differ. So it will row bind, and I will show you that. So R bind for the row bind, we will use the function, and I will show you this. Look at this. Got it? So in this way, we could merge the data frame. One more thing, suppose we have a different dimension in both the data frame, then how we could merge it? So at that moment, we should have one common column in all the data frame, what you want to merge. So here you see, I am making a data frame df1, that is the customer ID 126, and the product is the toaster and the radio 33. And data frame 2 is the customer ID 3478. This column is common in both. And the city, Bhopal and Indore. And I run this and this. I will show you this data frame first. So this is my first data frame. This is the df1. And I will show you the second data frame. This is my second data frame. So customer ID is a common column in both, and the product and city are the other columns, and the number of observations are different. Maybe the number of column may also be different. No problem. There may be another column there, and the column name is different. We could not C bind it. We could not R bind this. We don't have any option. So here we use the join function, inner underscore join, left underscore join, right underscore join, full underscore join. So this name you could give any name, XYZ. I have given here inner, here left, right, and full. These are the object name. You could give whatever you want. Function is this, syntax is this. So df1, df2, by which I want to join by the customer ID, which is a common column. So inner join means the intersection. It will give you the intersection. The intersection 1 to 6 we have here 3, 4, 7, 8. So 3, 4 is here also, and 3, 4 is here also in the first data frame. 3, 4 customer ID and 3, 4 customer ID in the two. So it will give me the data of the 3, 4. I will print it. You see, this is the inner join. 3 and 4 customer ID is in both the data frame. So it is giving me, inner join will give me that intersection. Left join, I will show you. So it will give me all the elements of the first data frame, all the IDs of the first data frame, and it will combine with the second. And wherever it is not applicable, it will give me the NA, and other which are it is getting, it will give me that way. Bhopal in 3 and 4, and 1 and 2 is not there in the data frame 2, and the 5, 6 is also not there. There is a right join also. In the right join, I will get the all elements of the second data frame. Three, 4, 7, 8 is the second data frame you see. So wherever I have in the data frame 1, I will get the value, otherwise I will get the NA. Now I have a full join. It will give me the all elements. Look at this. 1, 2, 3, 4, 5, 6, 7, 8. This is the full join of the both data set. Now we have some more. That is the semi and the anti join. This is the last one. Semi join is also a kind of intersection. That is the inner join, but it will give me the columns of the first data frame only. Okay, so I run this, and you will see it is the 3, 4. It is giving me the intersection, but the column of the first data frame, it is not giving me the column second data frame, which is the CT. That is the semi. Anti join will give me the elements which are not common in both the data frame. Or it will give me also the column of the first data frame only. It will not give me the column of the second data frame. Is it clear? Does that make sense to everyone? So this was over our this basic syntax R foundation, basic syntax concept I have explained you. Tomorrow we start with some descriptive analysis. Okay. And then we see how we could perform the descriptive analysis on R. Yes, somebody asked some question. You may ask, Kirti. Dr. Jagannath, would you like to ask some question? Yes.
So I have a doubt.
Yes.
So we use all these syntax to make changes in data frame.
Yeah.
But if we don't want to make any changes in data frame, suppose we have already made while we were entering them in Excel, and we exactly made columns and rows how we want it. So then we don't use syntax. Then we
no.
directly go to analysis.
Yes, yes. It is the pre-processing basically.
And so how do you remember like all the syntax, like what syntax does, what
There is,
function?
you see how many syntax we have read here. If you think, if you write in a copy, you have read only 10 to 15 syntax. 10 to 15 functions we have read. We have read the sub and g sub. We have read the paste and paste 0. Okay. Then we have read the substring sequence. So it is very few. When you do 1 or 2 or 3 times you do the practice, then you will remember it. It's not a big task. If you want to see the attributes, sometimes we don't know what we have to use inside. So I will give you the idea. It's very easy. Suppose you have to use a function substring. You don't know what is the arguments of this. So you do one thing. Before this, you just put one question mark and run it. You will see here. Just a moment. Look at here. X start stop. Getting? X is always the data. And they have given also X text, a character vector. Start first integer, the first element to be replaced. Hai? Stop last integer, the element to be replaced. Got it?
Okay, sir.
So you could easily get the attributes and you could get some functions also. You could copy these and paste and you could run it. Okay.
Okay.
Everything you could get here in R. There is no, you don't have to worry about it. So R will help you. Don't worry. We have here tutorial also. You could use this tutorial. Okay. You could use this also. If I start tutorial, then you will see. It will take little time.
So can we also calculate sample size for a study using R? Or do we
Yes.
use,
What sort of calculation?
like if you want to decide how much sample size is required for a particular study?
Yes,
Like
yes. We have the formula over there. We have so many techniques for calculation sample size. As per the population, we have to decide the sample size. Okay. So that we have the formula. We write there and we could find it out. There may be some package also. I have not used the package. I have used the formula. And generally, that's a very simple technique, simple formula are there for finding out the sample size. Not a big task.
Okay, sir.
No, so that we could calculate anywhere. You could calculate manually. You could calculate by the calculator on the Excel sheet, on the R also. Okay. There may be some package, but I don't have any idea. I have not used that because that is a very primary thing. For the data analysis, so we don't bother for that. It is the so this we could run the code 1 plus 1. If you run here, you will get the output 2. So in this way, you could learn also here. And you just stop it. If you want to stop this, then you see the red hexagonal stop sign is here. Just click this, then it will stop automatically. And then you use the console here. This is a terminal. This is the jobs. Okay. You can see. So these are our all thing. And someone also, Dr. Jagannath, would you like to ask something? Anybody else have any doubt, query? Darshana sir, can you once again explain semi-join, please? Semi-join is will give us the semi-line. Semi-join is just like a inner join, but it will give us the column of first data frame. Means the left data frame or the first data frame. Got it? Darshana? It will give the intersection only 3 and 4th observation it is giving us, but it will give the column of first data frame. It will not give the column of second data frame. So it is semi. Got it? Okay, so we wind up it. Tomorrow we meet at the same time, 5 p.m. Okay. I have shared the link today on the email of the course, whatever the 2 days stuffs, study material, everything, and the video link also. So you could access it from there. Okay. So thanks everyone. We wind up it.